Hi everyone. This session is deals with the topic of physical environmental mapping in GIS. It includes three main parts. First one, mapping and geographic information system. Second, managing the environment using GIS. Third, how GIS drives innovation across outdoor creation. First, mapping and geographic information system. A geographic information system is a system designed to capture, store, manipulate, analyze, manage, and present all types of geographical data. This can be used as tool in both problem solving and decision making, as well as for visualization of data in a spatial environment. Geospatial data can be analyzed to determine the location of features and the relationships to other features, what is happening nearby some features or phenomenon, where the most or least of some features exist, the density of features in a given space, what is happening inside an area of interest, and how a specific area has changed over time. Next, we elaborating those points. Mapping where things are. It is the basic feature of geographic information system, that is, we can map the spatial location of real world features and visualize the spatial relationships among them. The example shows sand mine locations and sandstone areas in Wisconsin. Second one, finding what is nearby. We can find out what is happening within a set distance of a feature, or even by mapping what is nearby using geoprocessing tools like buffer. Example shows the drive times from a central locations in the city of Madison. Then, mapping quantities. People map quantities such as where the most and least are to find places that meet their criteria or to see the relationships between places. This map shows the symmetry locations in Wisconsin. You can also gather the informations like which area has more symmetry and which area has less. Fourth one, mapping densities. Sometimes it is more important to map concentrations or a quantity normalized by area or total number. This example shows the population density of Manhattan. Then, fifth one, finding what is inside. We can use just to determine what is happening or what features are located inside a specific area or region. Example, below is a map showing a flood event and the tax parcels and buildings in the floodway. We can we can use tools like clip to determine which parcel fall inside the flood event. Further, we can use attributes of the parcels to determine potential cost of property damage. Sixth one, mapping change. We can map the change in a specific geographic area to anticipate future conditions, decide on a course of action, or to evaluate the result of an action or policy. Uh, this two map shows the land use changes in Barnstable from 1951 to 1999. Next session, managing the environment using GIS. How GIS can help in environmental management. Human activities and global warming are rapidly contributing to environmental degradation, decreasing glacial area, growth in glacial lake size, unprecedented rainfall, changes in land use and land cover, forest degradation, floods and glacial lake outburst floods, landslides, and shortfalls in agriculture, crop production are among the many problems brought on by environmental changes. These issues need timely monitoring and supervision. Effective monitoring of the environment and an improved understanding of the same requires valuable information and data that can be extracted through application of geospatial technologies such as remote sensing and GIS. This can be used most effectively for environmental data analysis and planning. This can provide a quick comparative view of hazards and risks and areas to be safeguarded. This can aid in hazard mitigation and future planning, air pollution and control, forest fire management, managing natural resources, wastewater management, oil spills and its remedial actions, etc. These are four ways of GIS in environmental protection or environmental management. First one, GIS in disaster management. Second, GIS in air quality monitoring. Third, GIS in forest fire management. Fourth, GIS in managing natural resources. First one, GIS in disaster management. Be it modeling through early warning system or using decision support system to understand which disaster is going to affect or is affecting which region is the most. This can help in mitigating the risks. Using GIS, preparation can be better, efforts can be more directed, and response can be faster. In the recent past, India has made great strides in the disaster alert system, be it cyclone alert, regional tsunami warning, or heavy rainfall or flood alert system. The Indian Tsunami Early Warning Center, based in Hyderabad, has been successful in delivering accurate alerts. Due to timely predictions, preparations have been better, even leading to timely evacuations and thus no loss of lives. This picture shows the stages of GIS in disaster management. First, preparedness, then recovery, rehabilitation, prevention and mitigation, relief, response, and prediction and warning. Second, GIS in air quality monitoring. Air quality monitoring has become an important part of healthy living, and GIS can play a very important role here as well. A GIS integrated platform by leveraging sensors and IoT for air quality monitoring, analytics, and planning can accurately predict the PM levels in varied areas within a city. Third one, GIS in forest fire management. Wildfire causes a huge loss to flora and fauna. The very first strategy to defend the forest against wildfire is to avoid it. This has provided its potential in forest fire management. There are different applications of GIS in forest fire management, out of which the most important ones are hazard map reduction, forest fire simulation, and resource management. Fourth one, GIS in managing natural resources. GIS helps in identifying the impact of human behavior on natural resources and lead to more effective utilization of the same. Data about natural resources could be collected through remote sensing, aerial photography, or satellite imagery, and then they are mapped using GIS technology. The major application of GIS in natural resource management is in confronting environmental issues like flood, landslide, soil erosion, drought, earthquake, climate change, habitat loss, population growth, etc. Along with the aforementioned applications, this can effectively aid in wastewater management, oil spilling, sewage treatment, etc. Next session, how GIS drives innovation across outdoor creation. Outdoor recreation resources are essential elements of strong communities. They improve quality of life by supporting economies, promoting healthy living, and fostering a stewardship ethic to sustain the environment. But maintaining these opportunities can be challenged by various factors, including tight budget, limited space, and even a pandemic. To strengthen our nation's outdoor recreation resources, communities need a multi pronged strategy that elevates effective asset management, improved public information forums, data driven budgeting, and sustainable resource management practices. This picture shows some of outdoor recreations like picnic, outdoor gym, cycling park, camping, etc. Here we explore four key aspects of managing outdoor resources. First one, monitoring and planning. Second, asset management and field maintenance. Third, executive engagement and cross agency collaboration. Fourth, civic engagement and public. First one, monitoring and planning. to ensure that it equitably meets the residents' need. Here is the basic. For example, ensuring that the space is accessible and suitable for visitors might require building new roads to and from the outdoor facility. Conducting environmental and engineering studies and determining what building materials to use for the projects are also part of the planning process. Case study: GIS dashboard re-engineering planning at Texas state parks. Challenge: in the Texas Department of Parks and Wildlife, regional directors and park managers have long been proponent of using data to guide their decisions. But data has not always been easy to use, with different divisions and programs within the agency using their own copies of spreadsheets to do their own analysis. They often ended up looking at very different data. There was no single source of information. And the solution is the Texas State Parks Insight Viewer now serves as that single source of information. Using this, the viewer brings together revenue, visitation, and capital construction data into an intuitive dashboard that enables regional directors, park managers, and other employees to conduct the kind of detailed analysis that just was not practical before. Second one, asset management and field maintenance. Not only must staff understand what is happening, but they must also empowered to respond. That empowerment comes in the form of having the necessary tools to communicate and collaborate across teams and departments to solve problems. This enables outdoor recreation staff to connect people in the field with their officers to restore, sustain, and protect the assets within their facilities while optimizing workflows. This enables them to better serve visitors and their staffs. Case study: Missouri State Parks implements a central asset management program. Challenge: Missouri's state park system contains 91 state parks and historic sites over 1,60,000 acres. With more than 2,000 structures, 3,500 campsites, 194 cabins, almost 2,000 picnic sites, and more than 1,000 miles of trail. Missouri State Parks was challenged to develop a way to effectively manage and maintain all of these various assets. And the solution is the organization established an enterprise just to inventory and manage more than 2,000 critical assets across the park system. Third one, executive engagement and cross agency collaboration. Sharing information and analysis with executive and multiple agencies is key to the success of thriving outdoor recreation facilities. This enables agencies to display critical information in dashboards that are readily accessible and easy to comprehend. Case study: New Jersey better informs executive to minimize closure. Challenge: in 2019, New Jersey Department of Environmental Protection saw a surge in harmful algal blooms in lake and reservoirs across the state. Because these blooms release toxins that can harm humans as well as aquatic life, the department issued advisories recommending against recreational activities like swimming and eating out fish. Such advisory frustrated residents and visitors. And the solution that changed in June 2020 when the department launched an interactive mapping tool. The web application presents data about water management to officials and the public in a clear and actionable manner. Next, civic engagement and public information sharing. The ability to regularly monitor and quickly respond to issues across recreational facility is not just a win for the staff charged with those duties. Ultimately, the real winners are the visitors. Overall, public safety and well maintained grounds are critical to the longevity of outdoor spaces. Case study: Cobb Country, Georgia uses GIS to lure in anglers. Challenge: Cobb Country Parks manage 12 local ponds. Many of them are fishable and open to the public, but staff must occasionally close the ponds for maintenance and development. Maintaining the ponds includes providing pond status updates for the public, information about what species of fish can be caught and kept or released, depending on the pond location. And the solution is online visitors to the Cobb Country Parks Pond website can search for the nearest pond using GIS powered maps that include imagery and photos of the sites, parking availability, locations of restrooms, and other amenities, and information on whether anglers can keep their catches. Park managers use an online survey tool to solicit feedback about visitors' catches and their overall fishing experience. Ultimately, this enables Cobb Country to unify its data and better educate, promote information, and solicit feedback. Next, how GIS supports outdoor recreation workflows. This picture shows the role of ArcGIS in outdoor recreation. Here is 6 major steps. First one is organize existing data. Second, collect new data. Third, perform analysis. Fourth, cross agency collaboration. Fifth, inform decision makers. Sixth, citizen engagement. And first step will be the seventh one. There is 4 basic steps in outdoor recreation workflow. First one, plan, then manage, then collaborate, then inform. Here is a conclusion. Environmental mapping system technology has become so important in recent years. Environmental mapping system allows us to integrate and draw associations between large environmental data sets which have a spatial reference, thus facilitating decision making and get a better understanding of geographic areas more effectively. They have been used for a variety of environmental applications, such as identifying areas with the most pollution. A geographic information system is a system composed of 5 fundamental pieces: data, technology, analysis, visualization, and organizational factors. Each of them plays a key role in developing environmental maps, which can be important for a variety of reasons. There are other tools and technologies that may resemble environmental mapping systems, but in reality do not share with them their ability to integrate under a single system a large number of elements and disciplines. This being the real difference that makes environmental mapping system stand out from the other tools. Here is the reference, and thank you.